Welcome to section 7.3, Simplifying Radicals, the Distance Formula, and Circles. Though we're not going over all the sections, we'll cover more of some of the sections in later chapters. Alright, so first off, the product rule for radicals. So if n is a natural number, that's basically 1, 2, 3, 4, and on, and the nth root of a and the nth root of b are real numbers, as usual. What do we know? Then the nth root of a times the nth root of b is going to equal the nth root of a times b. Now, careful. This is when they both have the same index. For example, if they're both square roots or both cube roots, what you can do is you can combine them under the same radical and just multiply the two inner ones together. So let's take a look at this. Multiply, assume that all variables represent positive real numbers. Why do they say this? Just because that is one of the qualifications. So let's take a look. Do both of these have the same radical? Well, we don't actually see a number, but remember, if we don't see a number, we're allowed to assume it's a square root. So they do, which means I can go ahead and rewrite it as the square root of 10 times 6y squared. And then we always have to check to see if we can simplify. This is the square root of 60y squared. Now, can I rewrite this as perfect square roots times the imperfects? What do I mean? Remember, I'm trying to simplify. So in 60, are there any perfect squares? Well, let's just break it down again. So 60 was 10 times 6, and 10 is 2 times 5, and 6 is 2 times 3. Do we see a number repeated twice? Yeah, 2. So I know there's a perfect square in here of 2 squared, or 4, times 5 times 3, and that equals 60. So we'll go ahead and write the perfect square in the first one, 2 squared, and then the imperfect, which was 5 times 3, so 15. So once again, what am I doing? I'm just breaking up this radical into the perfect square values and the imperfects, because I'm trying to simplify. And then let's take a look at y. Can I simplify that? Well, it's already perfect. It's y squared, so we'll go ahead and put that right there, and nothing else goes to the 15. So when we simplify the radical with those squares, we're left with 2y root 15. And we're done. Let's take a look at the next one. Do they have the same index? They do. They're both 4, so we'll go ahead and work with that. This is the fourth root of 8y cubed times 3r squared y. We'll go ahead and we can work on multiplying these. So 8 times 3, it's going to be 24. And then we have y to the 4th power, because we have that third and the 1. And then r squared. Now, this is the fourth root, sorry. Can we split this into perfect fourth roots? Well, I already see a fourth root in there, so I know that's going to be able to be simplified. R squared can't be simplified. 2 is too small. How about 24? Is there a perfect fourth power in there? Well, let's break it down. 24 is 2 times, what? 2 times 12. 12 is 2 times 6. 6 is 2 times 3. It looks like there's no perfect fourth root, because the most we can have is 2 to the 3rd power times 3. So all we can do is take out that y. So I'm going to go ahead and rewrite this with the perfect 4th power, and then the leftover is 24r squared. So those perfects cancel, and I'm left with y, 4th root of 24r squared. Okay, let's keep on solving. Quotient rule for radicals. Okay, so it's kind of pretty similar. Once again, we have the same things where n is a natural number, and this nth root of a and nth root of b are, and I'm going to go ahead and do this as mathematical notation, elements of the real numbers. Okay, that's what it means in shorthand notation, like emoji for math. Element of the real numbers. All right. So if we have the nth root of a divided by b, what we can do to simplify it is just split the radical with the top and the bottom. And notice, once again, you can go either way. If you have this way, you can get it into that form. If you have this form, you can get it into that form. It holds either direction. So let's go ahead and apply this. Example 2, we're going to go ahead and simplify. So, usually what I like to do is I like to see if I can simplify on the inside first before I do anything else. So can I simplify? I can. So 20 and 25 are both divisible by 5. 20 divided by 5 is 4. 5 divided by 5 is 5. So I'm left with the square root of 4 over 5. Now let's go ahead and split that. So the square root of 4 and the square root of 5. However, I cannot leave that radical down in the bottom. So I want to go ahead and match the index, would be a 2. So since 5 is to the first power, I'm going to figure out 5 times what will give me 5 squared. Once again, why am I looking for squared? Because I'm trying to match that index number. Well, 5 times 5 to the first power will give me 5 squared. So let's go ahead and multiply that to the top and the bottom. Once again, we're rationalizing the denominator. We're not allowed to have radicals in the denominator. Okay, and then that will be square root of 4, which is actually just 2, so I'll simplify that already. And then 5 divided by square root of 5 squared. The squares cancel each other. And we're left with 2 square root of 5 divided by 5. And we're done. All right, let's take a look at the next one. Can we simplify anything on the inside first? We can. We can simplify the 2 with the 16, so that'll be 1 on the top and 8 in the bottom. And that'll be the cube root of m to the 6th power divided by 8. Always simplify if you can. Well, there's nothing else I can do with a fraction, so I'll go ahead and split this up. That'll be the cube root of m to the 6th divided by the cube root of 8. Can we simplify? Well, the bottom one is a little easier. I know that 8 is 2 times 2 times 2. So I can rewrite that as the cube root of 2 cubed, and I know that that will cancel with the 3. However, m to the 6 is kind of tricky. I want to see if I can rewrite m to the 6 as 3 things times itself. That'll give me m to the 6th power. Which means I need m to some power times itself 3 times, and it'll give me m to the 6th power. But remember, we have the adding rule for exponents, so this is a little weird. 2 plus 2 plus 2 gives me 6, right? 2 plus 2 plus 2 would give me 6. So that means m to the 2nd power to the 3rd power would give me m to the 6th. Let's go ahead and rewrite that. Cube root of m to the 2nd power raised to the 3rd. And now we can go ahead. That 3 will cancel with that 3. And we have m squared over 2. And we've simplified it. All right, now let's take a look at the next one. Meaning of k to the n, root of a k to the m. Be careful, this one's a little weird. I don't use this one that often, but I'll go ahead and explain it. So once again, we have the same rules. M is an integer and n and k are natural numbers. So m is an integer, and k and n are natural numbers, which means, 1, 2, 3, 4. We're not including 0. And all roots exist. What does that mean? That means basically any square root you would take is a real number. Then what holds true? Well, k to the n divided by a k to the m is going to equal the nth root of a to the m. What just changed here? Well, basically, if you can find a common factor in the index number and the power, in some ways you can say you can cancel them out to simplify them. To just get n and m. Or, once again, you can always go in the reverse direction. Okay, so let's take a look at this following one. Simplify the square root of 7 times the cube root of 2. Well, how can we simplify them? We can't use the rule where we multiply them together because, look, they have different index numbers. We're kind of stuck. But actually, we're not really that stuck. What can we do? Well, let's translate them to their fraction powers. It's a little easier. So we have 7, and that'll be the half power, times 2 to the third power. Remember, the index is what the denominator is. Now what we're going to do is we're going to try to create the same fraction. Same base fraction. So how do we make 2 and 3 have the same base? Well, let's go ahead and create the common denominator of 6. So multiply this by 3 and by 3, and 2 and 2. And we've done this before with fractions, so that shouldn't be too new. So that'll be 7 to the 3 over 6 power times 2 to the 2 over 6 power. Why are we doing this? Well, we'll see in a second. Okay, so let's go ahead and translate this back into square roots, radicals. So that'll be the 6th root of 7 to the 3rd power times the 6th root of 2 to the 2nd power. Now, if you recall, now we can combine them because they have the same index on their radicals. So that's where the trick came in handy. So this will be the 6th root of what? 7 cubed times 2 squared. And then we just go ahead and write that out as 4 times 7 cubed. And that's just the 3rd power, so let's go ahead and multiply it out. 7 times 7 is 49. We still have to multiply one more 7. And then 7 times 9 is going to be 63. 7 times 4 is 28. Get 34. Okay, so that'll be 343, so 6th root of 4 times 343. Still going to multiply that out, so let's go ahead and do that on the side. 343 times 4, so that'll be 12, 16, 17, 12, 13. 1372. So that'll be the 6th root of 1372. And we're done. We put them under the same radical. So that's where the weird trick came in handy. Turn them into the fractions, and then do the building up property to create the same index numbers. Once again, that's the goal. That's how you combine them. So let's take a look at the next item, the Pythagorean Theorem. More than likely you've heard of this before. And if you want to look at the more in-depth definition, once again, that's in your book, page 477. So the Pythagorean Theorem, what is it, and why does it have that weird name? Well, basically, it's named after this Greek mathematician, Pythagoras, who figured out that there was a relationship. If you have a right triangle, what does that mean? There's a 90-degree angle. If you have a right triangle, there's a way to relate the lengths of each of the sides together. If you have leg A and B, and then the hypotenuse, C, what do we know? Well, if you square A, and then you add it to the square of B, they'll end up equaling C squared. A squared plus B squared equals C squared. Now I'm going to say this. This is a very important equation to have memorized in Math 103 and any of the other classes. It comes into play an awful lot. If you're talking about a triangle, this comes into play a lot of the time. Did I say that? Yeah, a lot of the time. All right. So let's go ahead and make use of this. Example 4. The hypotenuse of a right triangle is 12 units long, and the length of one leg is 6 units long. What is the length of the other leg? Well, all I hear are a bunch of words, so I'm going to go ahead and draw a picture. I like art. Is what I was going to major in at one point. So let's go ahead and draw myself a little nice right triangle. Careful. It said right triangle, so I know I can use this theorem. If it doesn't say right triangle, you can't just assume that you can use this equation, okay? So it needs to say right triangle. Ooh, that was a nasty bubbling. There, I fixed it. Okay, let's go ahead and label this. The hypotenuse is 12. So remember, the hypotenuse is the one across from the little house. It's the seashore. Okay. 12 units, and then one of the legs is 6 units. It doesn't matter which one, it just says 1. So the one we're missing, you could call it A or you could call it B. Doesn't really matter too much. I'll go ahead and say B is missing. So we want to find the length of the other leg. Now remember, if you use a diagram, you don't need to write a let statement. So I use the diagram, no need of a let statement. The next thing is I need an equation. Now since this is a right triangle, the natural thought is going to be, let's use this equation. And that'll be a good guess whenever you're working with a triangle. And it's a right triangle. It's a good guess to use that. So let's go ahead and write that down. Now my A value was 6. My B value we don't know. And then my c value is 12. And once again, note in the equation, it's our b value squared. Okay, so let's go ahead and solve. 6 squared is going to be 36, plus b squared is going to equal 12 squared is going to be 12 times 12, which I believe is 144. All right, and then solving, let's go ahead and subtract 36 from both sides. We're trying to solve for b. Okay, 144 minus 36 is going to be 108. And then we're going to go ahead and take the square root of both sides. Okay, so solving, to get rid of that square, we'll go ahead and square this side. Because remember, the square root will cancel the square. But we need to take the square to the other side. And now you'll notice in the book they say take the principal square root, which means the positive. But what I would like to see is you include the plus or minus. Why do I care about that? Well, let's say you find out that a number squared, remember a number times itself, you find out that that number squared is 4. So my question to you is, what are the two possible numbers that when I square them, I get 4? Well, the natural one most people think of is 2, right? 2 times 2. But there's another answer. There's also negative 2 times negative 2. So that's why I asked that you include the negative, because it's the possibility of the negative answer, not just the positive answer. Okay, so once again, if you ever take the square root in a problem, I expect to see that. That is something I grade for. All right, moving along. So b equals plus or minus the square root of 108. Now we need to see if 108 simplifies, because once again, we need to have simplified answers. Well, 108, is that divisible by 2? Yeah, that's going to be 54. And then 54 is even, so that should be divisible by 2 as well. 54 divided by 2 is 27. 27 is, I know that's 3 times 9, and then 9 is 3 times 3. Why am I doing this again? Because I'm trying to simplify the square root, so I'm looking for perfect squares. And I see that 2 appears twice, and 3 also appears twice. So I can rewrite 108 as 2 squared times 3 squared, and we still have that little 3 times 3. So b is going to equal plus or minus the square root of 2 squared times 3 squared, and then the imperfect, which is just 3. So that radical cancels with those perfect squares, and we're left with b equals plus or minus 2 times 3 square root of 3. Multiply those two together. b equals plus or minus 6 root 3. Once again, this is a word problem, so how should I answer? In word form. And this is where, as you'll notice in the book, it tells you just to find the principal answer, or the principal root, and that's because, let me rewrite this, the negative doesn't make sense for this problem because we're talking about the leg of a triangle, and it doesn't make sense to have negatives. But in some problems it does, which is why I ask that you continue to use the plus or minus. So what's my answer? The length of the other leg is what? 6 root 3, what's the unit? It doesn't give me a specific one, it just says units. So I'll just go ahead and write 6 root 3 units. And if for some reason the units are not given, just write units in place of whatever the unit would be. And now let's take a look at another formula. Distance formula. So, the distance, d, between the points, x sub 1 and y sub 1, and x sub 2, y sub 2, is given by the following. The distance equals the square root of x2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Oops, let me fix that. That should be under the radical. Okay, and this formula is kind of derived from the Pythagorean theorem. I'll give you a basic idea on it, and if you ever want to know a little more, just let me know and I can send you a video on it. So for example, if we're on the coordinate plane, remember we have our y values and our x, let's say we have a point here and a point here. And we want to find the distance between those 2 points. The idea is we create a right triangle, right? This looks like a right triangle. And all we do is we solve for the hypotenuse, which would mean we would have our a, b, and c. We'd have a squared plus b squared equals c squared. And this length here, which is c, in order to find that, we just take the square root of both sides. And c equals the a squared plus the b squared. So it kind of derives from that. Our a value comes from the difference between our x values, and our b comes from the difference between our y values. That was a bit of a quick explanation on where the formula comes from. If you want to know more, just let me know. Send me an email and I can send you a video or some other resource on how that or where it comes from. Alright, so find the distance between the pair of points 2, -1, and 5, 3. Well, it's talking about find the distance, so let's go use the distance formula. I always like to write down the formula first. And that's always, that's a good idea. If you maybe are pressed for time on the exam or something, you're not quite certain, if you even just write something down, let's say you write the formula down. Even if you don't actually use the formula in the problem, maybe you ran out of time, I'll at least know that you knew this formula should be used. And that'll earn you some points. So always, write down something, the formula for it or something, and you'll get some points for that. Alright, let's go ahead and fill in our points. So what you do is you pick one point to be the sub 1s, and the other to be the sub 2s. It doesn't matter which is which. I'll go ahead and pick these as sub 1s because, well, they were first. And that means this xy pair will be the sub 2s. So d is going to equal, and let me go ahead and color code this so it's a little easier to see. Let me actually go back and erase. I'll put you in green. So the sub 2s, we have x sub 2, it's going to be 5, minus, and our y sub 2 is going to be 2, our x sub 1. And then my y sub 2 is going to be 3, minus my y sub 1, which is -1. And gotta be careful, make sure to include your parentheses when you're working with a double negative. So then distance is going to equal the square root of, well, 5 minus 2 is 3, so 3 squared, plus, and 3 minus -1, that's a positive, that'll be 4 squared. Alright. So let's keep simplifying. So distance equals 3 squared is 9, plus 4 squared is 16. So that means the distance is going to equal the square root of 9 plus 16 is 25. Ooh, and that is a perfect square. D equals 5. And this is not a word problem, so you could just go ahead and write d equals 5 as your answer. Oh, and that is it. So if this was a word problem, talking about the distance from something to something, then you would write it out in a sentence. Other than that, that is it for this section. Please email me if you have any questions.